This is CSAT Sample Test 4, Question 12. The question is as follows. Consider square ABCD of side X and the equilateral triangle BCE as in the figure above. Here. We're told that the square rotates clockwise about B until A overlaps E, then around E until D overlaps with C, and so on, until A reaches its original position. We're asked to sketch the path traced by A and find its length, then give the length of the longest horizontal segment with endpoints on this path. Clearly the first thing we want to do is to sketch our path, since that will help with the second part. Let's consider the first few moves and see if we can spot some sort of pattern. Can you imagine what this will look like as we do it? It will be much easier to deal with if we can visualize it properly, so let's try drawing a new sketch. First, let's start with our initial position, and now let's rotate the square just as we're asked to do in the question. This ends up looking like this. How much have we rotated by? Will this be the same every time? We've rotated by this angle here, and since this is an equilateral triangle, this angle is pi by 3, and hence this angle that we rotate by is pi by 6. In fact, every time our situation looks the same but rotated, and so each time we rotate by pi by 6. How many times do we expect to rotate in total? We know that eventually A gets back to its starting point, so we rotated by 2 pi radians. And so we must make 12 rotations of size pi by 6. Let's keep going with our sketching. Next we rotate about A until D meets the corner of our triangle, like this. Then you can see that C moves to this corner, and then that B moves to this corner, giving us this situation. Is there anything special about this situation? Does it remind you of anything? Notice that what we've sketched here is a direct rotation of our original image by a third of a circle. And so we can see that after these 4 steps, we need to do the same operation again twice more to get A back to its starting point. We've rotated by a third of a circle, and we need to do so again twice more. So now we have a rough idea of what each step looks like. Let's try and sketch the path. So, first, A rotates around B down to this corner. This gives us a circular arc, looking like this. Then, in the next diagram, we rotate around A, so A does not move. Then, next we rotate C up to this vertex. What happens to A here? A is rotated about D by pi by 6 again, and ends up looking like this. And so, what does our arc look like? In fact, A maps up to where D used to be, here. Finally, what happens in this one? We're rotating A about C, which is in our bottom left at this point. This gives us a longer arc, which is no longer of side X, but instead the diagonal across the square. And that brings us to the end of this sequence. How can we sketch out the rest of it? Remember that we said that we would repeat this sequence 3 times to get our full rotation, all 12 steps. And so we can just copy this around the circle. One copy like this, and another completes the pattern. Now, how do we find the length of this path? What's special about the shape of it? Each part of the path is an arc of a circle. Why is this important to us? Remember that we know how to work out the lengths of arcs using the radius and the angle. What is the radius of the arcs in this diagram? For these short ones, the radius is the length AB. We're given in the question that this is x. Here. What about the long arcs? They have radius BD, the diagonal of the square. How can we find this length? By Pythagoras, we can work it out like this, considering it as a right angled triangle with 2 lengths x. And hence BD squared is x squared plus x squared, leaving BD as root 2x. What angle does each of the arcs draw out? Remember we said that every time we rotated by the same angle, pi by 6. And so we have that the short arcs have radius x, the long ones root 2x, and each rotation is by pi by 6. And so, how can we find the length? We simply need to add up all of our arcs. We have 6 short arcs and 3 long ones. remember the formula for our arc length is simply the radius times theta, when theta is in radians. And so our length is 6 lots of pi by 6 times x, plus 3 lots for our long arcs of pi by 6 by root 2x. We can take out a factor of pi and x that are in both, leaving us with 1 and root 2 over 2, giving us 1 plus root 2 over 2 times pi x for our length. Finally, in the second part of the question, we're asked to give the length of the longest horizontal segment with endpoints on the path. Can you see what this would be? The maximum distance horizontally from the middle is given by this point here and this point here, which are horizontally opposite. And so clearly from our sketch, this is the length we're looking for. How can we calculate this? There's a number of different ways to split this up into smaller segments or similar. The way I'm going to choose to do it is by considering the triangle FEJ. What are the advantages of doing this? Do we know what the length EF is? In fact, remember that when rotating, our point F is along the length of the square from E at this point, and it maps down to our point B as we rotate. This means that EB is the same as EF, and they're both x, and we can say the same for EJ by symmetry. Given that we know these two lengths, what would be useful to find FJ? If we knew the angle, we could use the cosine rule. What's the angle BEC? Remember, this is an equilateral triangle, so this will be pi by 3. Each of these two angles are subtended by rotating our square, and every rotation is by pi by 6. And so our angle FEJ is given by pi by 6 here, plus pi by 3, plus pi by 6, summing to 2 pi by 3. And remember, we said both of these lengths were x. Now, remember, our plan was to find FJ, and we can do this by using the cosine rule, which you should remember. Plugging in our values, we get that Fj squared is x squared plus x squared minus twice x squared cos 2 pi by 3. And so, collecting terms, factoring out x squared, and evaluating cos 2 by 3 to be minus a half, we get that this is 2 minus twice minus a half x squared, simplifying to 3x squared. And hence, our length Fj is given by root 3x. And this is our final answer for this question.